Solve trig equations. In this lesson, we're going to talk about how to solve trig equations in degree form. It's one of my favorite lessons, so let's get going. So the way you solve trig equations is it's kind of working backwards of the unit circle. So step one, we want to isolate the trig function. So we're it's like you can see here, this is already isolated. Sine of x equals 1/2. And then what we're going to do is use, all students take calculus, the sign chart, to draw triangles in appropriate quadrants. So for this one, you have to isolate already. Sine equals 1/2 x. So sine is positive. So if you use a thing, all students take calculus. My value is positive, so my triangle should be in quadrant A because it's always positive. Everything's positive in quadrant A, and then sine's positive in quadrant 2. So quadrant 1 and quadrant 2. And then 3. So this is where it deviates. If you do the table, you can look at the table now. If you do triangles, you use a triangle. So either use triangles or a table to figure out the reference angle. So that's what R8 is stand for. So we're going to figure out the reference angle by using either table or our triangles. Now, if you have the unit circle memorized, then all this is mute. I could tell you sine of 1/2, you should be able to tell me the angle automatically. But for the rest of us that are not insane, we're going to do one of these things. I'm a triangle guy, so I'm going to start with the triangle. So I drew my triangles like this. Sine is 1/2, so that means I use SOHCAHTOA. So specifically, right, sine is opposite of hypotenuse. Remember, the angle we're talking about is always the inside angle. It's always the angle. I don't care if you do table or triangle. It's always the inside angle. And then, so, opposite of hypotenuse. So my opposite's 1, my hypotenuse is 2. And it's true for both of them. Let's draw on this one, though. And just by looking at that, you should know what angle it is. Like, I could say this bottom one's right 3, because that's a triangle. 1, 2, right 3. But the fact that the opposite's 1 and the hypotenuse is 2, that lets me know this is a 30-degree triangle. Because remember, if you have your triangles memorized, seeing the 1 and the 2 there, and you can say the rat 3 down there, should let you know opposite 1 is always 30. Opposite 3 is 60. I don't care about that. Opposite 1 is 30. So this is a 30-degree triangle, which makes this one also a 30-degree triangle. And the last thing is figure out the angle from the origin. All I mean by that is, remember, your angle is not 30 and 30. That's the reference angle. Your angle is this guy, which for this first one is 30. And then this guy. Now, how do you figure out that? Well, the easiest way to figure that out is that we start at 0. This is 90. This is 180. So we're 30 short of 180. We're 30 away from 180. That makes this 150. And those are my answers. 30 and 150. Now, if you're doing the table, how does this change? The only thing that changes, instead of using the 1/2 to figure out the fact that instead of doing the triangle, trying to remember what opposite 1 is, and when you look at the table and you see a sine of 1/2, it just says 30 degrees. So in the table, it just tells you, oh yeah, these are 30 degrees. Done. But then you still have to do this part. Only thing that changes is step 3. If you do the table or triangle, step 1, 2, and 4 are all the same. 3 is the only one that changes. Do you have the triangles memorized? Or do you have the table written down somewhere after you memorized it? So that's the steps, and we're going to basically do this for the rest of the lesson. So for tan here, because set equals, we're going to solve it, get it isolated, so subtract 3 from both sides. Tan of x equals 1. So I draw my little triangle. All students take calculus. Now, one's actually a very special result that for tan we can actually make a triangle for, but we'll see in a second that it doesn't work for all things. So tan is positive at A, because everything's positive at A, and T, because T stands for tan. Alright, and now, again, you can use a table. On your table, just where does tan equal 1 at? Or, if you're using a triangle, I think of tan as 1/1 and TOA, opposite over adjacent. So, here's my angles. A 1 and 1. So only thing that has a 1 and a 1 is the isosceles triangle, so it's 45 degrees. Like that. And again, the last part of this is you got to find the angle from the origin. So we're looking for, this is 0. We're looking for this guy. Quadrant 1 is so easy, it's just the angle, 45. And we're looking for this guy, the angle from here all the way to there. We're looking for there. Now this one, just like we did last time, you look for the nearest x-intercept. We always go to the x, not the y. So this is 180. And we went past 180, right? We went all the way around. So we went 180 plus another 45. So 225. So it's 45 and 225. And that's how we do these, right? So if your angle's over here, you're going to go 180 plus the angle you found. If your angle's over here, you can do 180 minus the angle you found. If you're in quadrant 1, it's just the angle. And if you're in quadrant 4, the easiest way to do it is to go 360 and then subtract the angle you need to go backwards. So it's either, to me, I always think about it, do I have to go forward or go back? So if I'm over here, I have to go back. If I'm over here, I have to go back. If I'm in this one, I got to go forward, so you add. Next one, cosine plus 1 equals 0. So we're going to do the same thing. We're going to solve for cosine, get cosine by itself. Cosine x equals -1. Now here's the thing about this one. If I try to do the same trick, opposite of adjacent, so it's in the right, it's actually the wrong quadrant, but still, I get something like this. That's not a triangle. I can't have one be a side and hypotenuse. Hypotenuse has to be the biggest thing. This is not a triangle. So let me erase this. And this is something you're just going to memorize or get used to, is that if theta equals, not theta, if sine or cosine equals -1, 1, or 0, it's a unit circle. Tan could do 1. It can't do 0, but tan could do 1 and -1. Sine and cosine can't. Sine and cosine, like tan, what I mean by that is 1 for tan is a triangle. Sine and cosine is not a triangle, it's on the unit circle. What I mean by that, it's one of these points on the unit circle. It's either this guy, this guy, this guy, or this guy. It's either 1, 0, which happens at 0, 0, 1, which happens at 90, -1, 0, which happens at 180, or it's 0, -1, which happens at 270. And it's going to go around at 360. You should all have degree marks on them, by the way. So right now, right, we're looking for where does cosine equals -1. So remember the way we do this is sine e, sine is the y value, cosine is the x value. So I want cosine to be -1. Look at your x values. Where's the -1 at? It's -1 at 180 degrees. So that's how we do the quadrantal angles when it's going backwards. So most of it's just gotta remember that if it's -1, 1, or 0 for the sine or cosine, it's a quadrantal angle. It's on the unit circle. So let's do some more. So this one's a couple things about this one. It's a little fancier. It's not just a basic one. And second, notice the domain. The only one from 0 to 180. If you look at the one we'd up here, not this one, this one, 0 to 180 is this top half. So my answer actually only would have been 45. This would have been too big. So to keep that in mind when they specify the domain. So here, how do I solve this one? Well, it's already said equals 0, so now we can have to factor it. They both have a cosine, so we could factor out a cosine. So cosine theta equals sine of theta minus 1/2 equals 0. So you actually factor out a cosine. It's like a normal problem, like a normal equation. Factor out cosine for both. You have this, it equals 0, so then you can use the zero product property, which means you can split it. And cosine theta equals 0. And sine of theta equals 1/2. Sorry. We go too fast. Sine minus 1/2 equals 0. Then we just solve each one separately. Cosine equals 0. Remember, that's one of the special ones. It's on the unit circle. So this is 0, and that's 1, 0. This is 90, and that's 0, 1. This is 180, and that's -1, 0. I would go further, but remember, my domain is only from 0 to 180, so that's all I care about. Cosine the x value. So look at your x's, and the only one that equals 0 is 90 degrees. So that's one answer. Now we have to solve where does sine equal 1/2. Sine minus 1/2 equals 0. So solve for sine. Add the 1/2 to both sides. We get sine of theta equals 1/2. Now we just got to solve it. Remember, first step is all students take calculus, figure out where it should go. It is positive, so it's in quadrant 1 and quadrant 2. Remember, if you're positive, you're always in quadrant 1, and then it depends on which trig function you have. I have sine, so the second one's positive. Either use the table, where does sine equal 1/2? It will say 30 degrees. Use the table, the table is 1, it'll tell you 30 degrees. If you use a triangle, 1/2, opposite of being 1/2, opposite being 2 is 30 degrees. Anyway, once you have that, don't forget that's not our answer. Our answer is this angle, which is 30. And this angle, and since this is 180, that's 30 degrees back, right? This is all the way 180. You have to go back 30 degrees, so it's 150 degrees. So you have 3 answers. We have 90 from the unit circle. We have 30 degrees, and we have 150 degrees. All those fall within the domain 0 to 180. This one we haven't learned yet, so I actually got to skip that one. So the next one. Infinitely many solutions. So solve 2 sine theta equals -1 for all values of theta. Well, we're not doing radians here, we're doing degrees. So for all values, no domain. Over here said 0 to 180. Some of the other ones we did 0 1 360. I didn't talk about it because that's a generic one. Now we want for all values. We'll talk about this. So first, let's solve it. I get sine by itself. So divide by 2. Sine of theta equals -1/2. So we start out the same way. All students take calculus. We're actually a negative sign now. So A and S is where sine's positive. It's negative the other two. So T and C. Like that. Again, you can use a table or you can use a triangle. I'm a fan of the triangle, so I'd go opposites -1/2, opposites 2. And I just need to do on one of them. I just got to figure out what angle that is. Opposite being 1 is 30, and then with hypotenuse just being 2 is 30 degrees. If hypotenuse was radical 2, it would be 45, but 1 and 2 is 30. Anyway, that means that's 30 and this is 30. Remember, that's not my answer though. The answer is the angle we get from the origin. So my answer is starting from here. What are those angles? I go all the way down to here. And the way we do that's figure out the nearest x-axis. This is 180. And we had to go an extra 30. So we went 180 and we went an extra 30. So 210. And then we got to get this angle here. So starting from the origin all the way to here. By the way, I don't generally draw these lines like I'm doing it myself. This is just because I'm teaching. If you're doing it, you don't have to draw lines. You just figure it out. And what's the nearest x-axis? This one. Remember, we always try, it's a reference thing. We always go to x-axis. So this is 360, and we haven't got there yet. We're short. Right? We're 30 away from 360. So you subtract 30, and you go 330. So my answers are 210. Theta equals 210 and 330. But remember, they said for all values of this. So it's a circle. You could go around a circle as many times as you want. So the way we compensate for that is anytime they want that, we just go plus 360 n. Plus 360 n. Because you get 210, you just add, you go around in circles or backwards in circles as many times as you want. So anytime they want like all the values, you just do that. Find your one answer, add 360 n to it. And because let's multiply any value by n. And the same thing for the other answer. So that's what you cover all answers. That's what you're supposed to do anytime they don't give you a domain. Just put every single possible answer there. Okay, let's talk about extraneous solutions. So this is when we solve it and then one of the answers doesn't work. Because another thing we talked about before is that sine and cosine had to be between 1 and -1. Right, the unit circle. Sine and cosine can't be bigger than 1 or -1. Tan can because tan's a ratio of those two, so ratios could be a little funky. But sine and cosine has to be between 1 and -1. So you get something that's too big, like here. Cosine theta equals 4, that means you have no solution because you can't solve that. And again, we're doing it from 0 to 360. We'll do radians later in the year. Okay, so this first one. How do we solve this? 2 sine squared theta minus 3 sine theta minus 2. That looks ugly, but it should look kind of familiar. This is a quadratic. If you just ignore sine for now, and make it like an x, like something you're used to. Okay, this is 2x squared minus 3x minus 2 equals 0. You would factor it and set equal to 0, like factor and split it, right? The way you solve a quadratic, you set equal to 0 and you factor it. So that's what we're going to do here. Now there's lots of ways to factor this. You can do it any way you want. I'm going to multiply the first term and the last term. I get negative 4x squared, then find the combination that gets me the middle term. Two things that multiply to get negative 4, but add to get negative 3. That'll be negative 4x and positive 1x. When you multiply them, you get negative 4. Add them, you get negative 3. Then I'm going to substitute that in for the middle term. So the first term and last term stay the same. The middle term turns into negative 4x plus 1x. Then I'm going to factor by grouping. So 2x, x minus 2, bring down the middle term. These guys have nothing in common, so bring it factor out of 1, x minus 2. These both have an x minus 2, so x minus 2, 2x plus 1 equals 0. Now remember, so I factored it. So now I go back and go, wait, remember it's not x, it's sine. I just used x to replace sine. So our actual thing is sine of theta minus 2 and 2 sine of theta plus 1 equals 0. Split and solve each one separately. So sine of theta minus 2 equals 0. 2 sine of theta should be theta plus 1 equals 0. I get sine of theta equals 2. And sine of theta equals negative 1/2. Now sine of theta equals 2, you actually can't solve. It's too big. Remember, sine cone between negative 1 and 1, to be anything like this, no solution. Can't solve that. This we can solve. We're going to side equal negative 1/2. We did this earlier, so hopefully by now we can start memorizing it. I also need to take calculus. So it's sine is negative, so it's on the bottom two because sine is positive a and s. Here's my angle. Opposite's negative 1, opposite's 2. That's a 30-degree angle. Done a lot of 30-degree angles today. You start at 0. This is 180. You go 30 past that, so 210. And then here's 360. And you're 30 short, so we're at 330. So my answers are 210 and 330. So that's the point of this one was right. Sometimes you can get no solution. If you have sine or cosine and it equals a number bigger than 1, you can't solve it, so you get no solution. The next one, sine of 2 theta equals negative rad 3 over 2. What do I do with that 2 theta? It's kind of what we did last time. What I like to say is you ignore it to the end. Ignore till the end. Some people call that like a U substitution or like a W substitution. So you just say like, you just pretend to W. W equals 2 theta, and you just solve it like normal. But really I just kind of say, ignore this till the end, and then we'll solve it. So let's solve this part first. Where does sine equal negative rad 3 over 2? So, all students take calculus. Sine's positive at a and s. We're negative it down here. That's our angle. That's our angle. Again, I don't care if you want to solve this with a table, and you look at the table where does sine equal negative rad 3 over 2, or if you do it with triangles. Opposite would be, right, SOHCAHTOA, negative rad 3, opposite would be 2. If you remember what's opposite of rad 3 is the biggest one, so it's 60 degrees. So my answer here would be 60 degrees. That's not the full answer though, because remember, we need the angle from the origin. So you're starting here. We need to go all the way down to here. So we find this is 180. We had to go 60 past 180, so we got 240. 60 plus 180 is 240. And the same thing for this one. I'm going to go all the way around to here. Again, this is 60 degrees, because same triangle. But this is 360, the closest thing we have. And we're 60 short. We haven't got there yet. We're 60 behind 360, so we get 300. So I get W equals 240 and 300. Now here's the thing. Remember, I said ignore to the end. We're at the end now. So remember, we didn't solve for W. We're solving for 2 theta. So at the end you put 2 theta back. And 2 theta equals 240 and 300. Then you divide by 2. And theta equals 120 and 150. It actually gets a little bit more complicated than that. We have to worry about the domain, but we'll talk about that at a later date. Okay, now that we know that, we're just going to do a couple more examples just to make sure we have it. So this one right here, notice there's two signs here, but we solved the same way. It's already set equal to 0. This one we could factor out a sign. So you factor out a sign, and you get this. So we get sine theta times sine theta minus 1, because they both have a sign, you pull it out. Now you could split it. Sine of theta equals 0. Sine of theta minus 1 equals 0. So sine of theta equals 1. So we have to solve sine theta equals 0 and sine theta equals 1. Now these are both unit circle things, right? So you can't make a triangle with 0, you can't make a triangle with 1 unless it's tan. So these are on the unit circle. So let's draw a unit circle real quick. 1, 0. 0, 1. Negative 1, 0. 0, negative 1. And then go over. This would be at 90, 180, 270, and 360. Okay. Now it actually doesn't have a domain here, so we'll just solve it and we'll add the plus 360 in. We'll just do for everything. So where does sine equals 0 at? Well, sine equals 0 here. Remember, sine's the y value. Sine e. Sine goes with y. Trying to get the y values. So where does sine equal 0? Sine equals 0 at 0, and it equals 0 at 180. So you could say theta equals 0, and then 180. Now if we're doing it at any point, you would say sine equals 0 plus 360n, and then 180 equals 0 plus 360n. We're going to do it for any point in the world. And if you notice a shortcut for this one, we actually don't need this one right here. If your answer is at 0 and 180 and then 360, you're just adding 180 every single time. So you actually could just cut one of these out and just put sine equals 0 plus 180. Like that. So it's a little more efficient. Where does sine equal 1 at? Sine equals 1 right here at 90 degrees. This one doesn't follow the same pattern though. It doesn't. If I add 180 to it, I don't get the same answer. So this would be the plus 360. So there's my answers. Now again, if the question was between 0 and 360, my answers would be 0, 90, and 180. But I forgot to give you a value here, so I just did all of them, which is just get your answer at 360, which we did here first. But then we noticed a shortcut where, in this case, every 180 was repeating. So let's do a little shortcut. Okay, last one. So 2 cosine squared equals 1. So we're going to divide by 2. So I get cosine squared theta equals 1/2. Now I have the square, so I can get rid of that. So we're going to square root both sides. So we're going to get cosine theta equals plus and minus radical 1 over 2, also just known as rad 2, 1 over rad 2, plus and minus. If we took a square root, so plus and minus. So what does that mean when we draw our triangles? Well, we're sine and cosine. I need cosine where it's positive or negative. So students, take calculus. It's every quadrant. Right. Cosine is positive at A and C. It's negative at S and T. Every quadrant. So if it's between 0 and 360, I'll just put every single quadrant there. I got to find the angle either way. Now, here's a shortcut. Anytime you see rad 2, dead giveaway 45-degree angle. Only triangle that has a rad 2 in the special triangles we know is a 45-degree triangle. So you do cosine 1 rad 2, but that's a dead giveaway. It's a 45-degree triangle. So this is 45. Over here, this is 180, but we're 45 degrees short, right? So we have to go back up 45 degrees. So 180 minus 45 would be 135. And then down here, we have to go 45 more, so it's 180 plus 45 to get down here, so 225. And then the last one here, right? This is 0 and 360. We haven't got to the 360 yet. We're 45 away from 360, so 360 minus 45 is 315. So my answers between 0 and 360 are 45, 135, 225, and 315. Now again, if they wanted it for, like, I forgot to put the domain here, so if they wanted for every single answer, you would go plus 360 and plus 360 and plus 360 in. But even if it's another one where you could make it shorter, you could go, wait, if I just do 45, I add 180 to that, I get this. So if you want them from all of them, you just go 45 plus 180 in. That gets you these two, right? And if you do over here 135, you can go plus 180, you get 315. And this goes around again. See if you want it. So you can also say, so this is good for 0 to 360. If you want for every single answer, it would be 135 plus 180, and you get the same answer. So either way, anyway, that's it.